Welcome to the lecture on XML, and today we will talk about processing with XML processors. So what is that all about? Well, we learned already that XML documents have to be consistent in the context of certain rules on how to write these XML documents, and we also learned about two different ways, the document type definition and the XML schema, that allow us to specify certain grammars that have to be taken care of in the sense of making the XML document, the data and the markup valid in the context of the grammar. So now that we have these documents with or without grammar, valid documents in the context of grammar, well-formed in the context of the rules, now that we have that we can share these documents, the question is, and what can I do with it? And this is the major topic for today. So how can I use and make use of an XML document? How can I get the data out of that document, and who can support me in using the XML document from some source, and who helps me in reading these documents, or do I have to do this all on my own? And the answer to that is, well, you can do this writing a program that reads the data out of the file or out of the stream that you might read, and actually it's not too difficult to do so. But the question is, why should you do this? Because we have tools for that. And let's talk about the first tool, which is an XML process called the XACS parser. And there's another one, which we will talk about in a minute, quickly after the XACS parser, which is called the DOM parser. So both parsers are very well known, standardized in certain to a certain extent, which we will also talk about in more detail later in the session. So first of all, what we have here when we are talking about an XML processor is we have on the one hand side an XML document. On the other hand side, we have an application, some software application that wants to make use of the data in the XML document, and the XML processor helps the application, the development of the application, to specify an API or by use of an API of the XML processor to specify a well-defined, standardized kind of way to read data from the XML document and even write data to the XML document. We will talk about two different reading approaches, the XACS parser and the DOM parser. We will not take time for too much time for the context of writing, but in the tutorials we will talk about this as well. So let's start with a simple API for XML, or as the acronym says, XACS parser. So the XACS project started with the first documentation of this XML standard in the end of 1997. The XACS project started, and in the beginning of 1998 there was already the first XACS parser available, and also principle or a methodology on how to deal with XML document, a certain program paradigm, if you like, an event-driven processing of XML documents that allowed to made a very easy approach to make use out of the data in the XML document. The parser came with a very, very simple, as I said, event-driven paradigm, some kind of push model to program the parser. And it defined, or the parser came with a very simple API, having only 3 so-called callback methods that you could use to use the parser in reading the XML documents. So the API that the SAX parser established were these three here: the start element, end element, and characters. The start element here, or start element code element here, was always, or is always called, or an event is thrown to that starts this function, the start element function, whenever the parser finds a start tag in the XML document. And an end element is behaving very similar. The parser throws an event so that the end element is called whenever an end tag is found. And the content model of an element contains characters in the most simple way. And whenever that happens, the character event is thrown, and which invokes in the end the characters function. So how does it look like? Let's think about a very simple XML document. This one here to the right, having the root element person, a sub element alter, or age if you like, 12, some characters, an end alter and end person element. So this is the document which we feed into the push parser, the SAX parser, and the program that we develop is written here, the callback definitions. So our application that we write contains whatever code, but most importantly, it contains three callback definitions: one for start element, one for end element, and one for characters. And these three callbacks are always called, well, as the names of these callbacks says. Start element is always called when a start element is found by the push parser. Characters is called when characters are found. End element is called when the end element is found. So let's push this XML document into the parser. And as you can see here, the first element that the parser will activate is an event thrown because the parser finds an element called person. So the start element person is called. And if you look into the code of start element here, then there is an if clause asking for the element name. And if the element name is alter, then it will invoke some print function. As the element name is called person, so person, we do not have any code executed. So the event is, or the callback here, the callback function is doing in the end nothing. So then as next part, the parser goes into the subtree of person and finds the element alter. Again, the start element alter is called, or an event is thrown, and again the if clause is checked. elim.name equals alter. This time it's resulting in true, so the function, the if clause is executed, and this text is printed. So your alter ist colon, which means your age is. Following the XML document, this XML stream, there is now some characters following 1 and 2. And again, these characters are found by the parser. The parser throws or invokes this function here, this callback, and the characters that are part of the callback are printed immediately. So that's why we then have as output altogether so far at this point in time side of the document, at this position here at the end of 12, we have Ihr Alter ist 12. Your age is 12. And then the parser moves on character by character, finding an end element, which is indicated by these two characters here, the smaller sign and the slash. And then it follows the element name and the upper or greater sign. And now we have, or the parser has detected an end element. And as you can see here, the fourth event that the parser throws is an end element with the name alter. So in our callback definitions for end element, we just say, okay, please do not do anything with an end element. So the parser moves on, finding the next end element, which is this time the end person element. As we know, each starting element also requires a ending element. So we have this also for person. Again, the event is thrown, end element person. The callback definition is called here, and but in this sense, again, it doesn't have to conduct any other code. So we are reaching the end of this XML document. The push parser has done its work, and we have evaluated or processed, to be more precise, process the XML document in one step, in one pass, by just going from the first character, the smaller sign here, to the greater sign here, character by character, identifying start elements, end elements, and characters. The advantage of this approach is this parser is super fast. And this parser is also super simple. It does not have to think about a lot of stuff. It just goes through the text, through the document, character by character, identifying elements and ending elements and characters. And that's it, what the parser does. It just goes and throws these events, and they are then executed very fast. And that also means it can deal with extremely big XML documents, because there is nothing that the parser has to do with the document. It just goes through the document from the early beginning until the end, and does not have to save any kind of information, any kind of context. The parser is very fast because it is such a dumb approach to dealing with XML documents. So this is the most important advantage of that parser. It can deal with the biggest XML documents, and it is super fast. The problem is it is also super simple. So whenever we would like to search for anything inside of an XML document, when we would like to look back or go for and back and navigate in the XML document, so from subtree to the neighborhood, or to another subtree, or to a father, to a parent node, all this is not possible with the SAX parser, because the SAX parser does not have any knowledge about the document. It just goes through the document character by character. Okay. So there is a question why we call this parser a push parser, because it goes through the stream of characters, through the stream of items that the parser can detect, and it then pushes out events, like you see here: start event, characters, end element, and that is the way it's called. Okay, nothing very special. Okay, good. So that's the SAX parser. Very simple. Problematic is if you want to have a little bit more of luxury in the context of dealing with the elements, if we know the structure, if we have, for instance, grammar defined, and we know that there is in the early beginning of the document, at the end of the document, data that we are looking for, well, then it's depending on how we can match these things, how we can look for that, and we have to make the programming of our application a little bit more complex, because the SAX parser does not support us in any kind of dealing with structure. It just goes through the elements and the characters and pushes out some events. That's why there is the other parser, which is a little bit more complexity in this context coming up. We are not talking about a parser anymore. We are talking about something bigger, and that's called the document object model, or in short, DOM. The document object model is, first of all, a W3C standard. It's a recommendation, and as a homework, as usual, you should go to the W3C and take a look at this specification. The specification is very interesting to let's say, to take a look at. You probably won't read the whole documentation, even if you would like to, but please don't do it. Just take a look at it. But that is a focused look and a look over, so skimming over the whole document and taking some time from time to time to read parts of that specification. The specification describes an API for XML and HTML documents. So it's both. It's dealing with XML and HTML documents. And the most important thing is it describes an API independent of the programming language. So this is very important because this principle is used also in other contexts and might be used in the future. And therefore, it's definitely interesting to take a look at how that feels, how that reads, how this is done, because that makes you faster if you have to learn new APIs in this context in the near future. So what does it mean? An API for XML and HTML documents without talking about the programming language? Well, the API that you can read about and the data structures that you can read about in this W3C recommendation are abstract objects or data structures and abstract API names and their signatures. So it's a document, a specification, which describes the names, signatures, data types, all the structure of an HTML, all the structures of an XML document. So its logical form, how you can access certain data types, how you can modify certain data types without defining it through a specific programming language like Java or C#, but it describes it in a fancy kind of W3C unknown, not existing programming language. It just describes some names. And the idea is that if you implement this specification as part of your Java programming language or as part of your C# programming language, then you have to implement the data structures and the functions, procedures, or methods and their signatures exactly in the way that the W3C standard is recommending it. So if you have, for instance, a function ABC, which has in the signature a data type called W3C integer, and this function ABC returns, let's say, some element, a list of elements, then you can read in this document type, in this document definition, or in this recommendation, how this list is implemented. Also, again, in an abstract way. And if you are now implementing this standard using C#, then you have to implement data types which are exactly implemented in the way the specification describes it. And you also have to use the names from the specification. Same if you implement these things in Java. So if you read the specification and you know the terms, the data structures, method names, and everything, and you know how to develop in Java or in JavaScript or in C# or whatever kind of programming language you know of or which will be developed in the future, if these language implement something in the context of XML documents, in the context of the document object model, then you already know how these functions and method names are called and how it works. So regarding the standard itself, this is a standard which comes in a set of different documents. There is the document object model level 1, where the focus is on objects. So here you find all these specifications of objects and structure. The level 2 focuses on events and style sheets. We will talk about style sheets and all these kinds of things later on in the context of XSL. And the level 3 is focusing on XParse, loading and saving documents, and a couple of other management-oriented aspects. And we will talk about XParse in more detail because it's so important, also in a dedicated section. That's it. That is the specification. There's also another document which introduces you a little bit to the overall structure of DOM level 1 to 3. So this is the core specification, which you can also read about and which I would recommend that you take a look at. And it's started in 2004. So quite a little bit after all the SAX parser activities, and it is a recommendation. And that means what you learn here in this context stays for a longer while, which is highly important because that means what you learn here is available also in the next couple of years after the study. Okay, so let's talk about some objects. In this specification, they have a couple of classes presenting the objects for an XML document. Most importantly is the object called node. So an XML document consists of a set of nodes, and there are different types of nodes. So in the context of inheritance, a document, an element, an attribute, a CData subclass are all inheriting from the node class, if you like. So a document is a node representing the overall context of the set of nodes representing the XML document. And this XML document consists of a set of elements in their hierarchy building the XML document. Each element might have a set of attributes, a list of attributes. A node list might be the best term to represent that. And an element, if the content model allows for it, can have character data. To make life as a programmer a little bit easier, we might also have a so-called named node map where we can use identifier and other aspects to have a way to find from a name the corresponding node element a little bit quicker. And that's it, more or less. So these are the most important objects defined by the DOM level 1 application. And with these objects and the knowledge about these objects that we have now, we know that in C# there is a data type called element, or there is a data type called node. And the same is true for developing with Java, where we have a node object or class and an element which we can use in our programming whenever we deal in Java with some XML document. Okay, the W3C foundation describes also how to interact with a node or with an element or with all the other classes that we have. And here I copied a little section out of that specification for the interface or for the class of node. So this is a data type node specified in the language of the W3C, in an interface definition language, if you like, an IDL. So the node class, the interface to that node element, which all programming languages have to implement if they want to be compliant with this specification, they have to provide some kind of read-only attribute for the node name, and there must be some string representing the node value. And then you have, as you can see here, a couple of other attributes where you as a developer can ask, for instance, okay, what type of node am I dealing with? Is this an attribute or is this an element or character section? Or is this a document element itself? And depending on what type you have, you might also get some meaning out of these other attributes. So for instance, does your node has a parent node or child nodes? Is there a sibling? the previous one, the next sibling. So having all these attributes available, you can navigate through this hierarchy of nodes and subnodes and siblings, and from a sibling you can navigate again back to the parent node or to your child nodes if you like and if you have them. If you don't have them, then you can also manipulate the node by activating methods for inserting or replacing childs or removing childs or appending child nodes, so that you are directly operating on a node which is part of the document node. So here we have an example for very simple XML document. The root element is called person. There's an attribute called name. Then the value of that attribute is Peter Pater. We have a telephone or a tel element, 1, 2, 3, a fax element, 888, an H, 1, 2, PW, acronym for password, for instance, or a mail element or M element for the mail address, and an end element person. So we have a very simple XML document which contains contact data, if you like. So how can we make use of it when using the DOM approach instead of the SAX parser approach? Remember, if we use SAX parser, we have to create callback functions for all these different elements. And now the beauty of the document object model approach. So now that we say, okay, we are using the document object model, we can just create a document object model, a DOM parser, and creating with this DOM parser, we are creating a document, an XML document, and we can simply say, please load the file or the stream into this document object. And that is done automatically. And as soon as it's loaded, the elements that are in this XML document included, they are put into the structure by having this or using these different node types and making copying the structure of the XML file into this object model. So we have for each element in the file, we have a corresponding node for our object of type node in our document object model object. So this object is full of subclasses or sub-objects, all in the memory of the computer, so we can access now these different objects in a very elegant programmatic way. So for instance, we start with a document node and ask for the last child, which is the person element here. You can also ask for the first child. It would be the same person element because our document has only one root element. So now being here, we can ask the object person for its first child, which is the tel element, the tel element, and the last one would be the M element. So the last child is the M element, and one other child is the age element. The age element is a child element of person, and the age element, being a child element of person, has as parent element the person element, of course. Age comes with a character content model. So the first and the last child is the character 12. So you see, there is immediately a lot of structure, and it's super fantastic and super easy to do the programming if you have an XML document which is valid in the context of some grammar. So you can make sure that it is corresponding and aligned with the rules that are specified by the grammar. So you get that document with all the data from another computer, which might be a completely different system, different architecture, different operating system, everything different. But you still can talk with each other because the documents that are shared between the totally different computers are standardized using XML, and you can use whatever kind of programming language. If that programming language supports the implementation of the DOM standard, then you can immediately use the programming tools and equipment that you have specified in the standard and make it and apply it in your programming language. So here we have a question. Do you know why the W3C decided that attributes should inherited from the nodes class and should be nodes themselves? Wouldn't it be more intuitive if attributes were real attributes of element objects? Maybe. It depends a little bit on how you deal with it. From the programming point of view, I would agree what you suggest. From the programming point of view, making things a little bit easier in the web for the developers, well, then it's probably easy to have only a limited set of classes and complexity, so that you do not have to decide or have to use a different object type for attributes. And probably it's one of the reasons, but I do not know. It's just a guess. So I can try to find it out, and maybe I can find a person who knows and will ask for it. Thanks for the question. Okay, so here's a screenshot from Visual Studio, from Microsoft's Visual Studio. Very simple afternoon hack kind of thing. If you use the namespace, the assembly system.xml, that is an implementation in Microsoft's .NET assembly. Microsoft supports the W3C standard, like most of the other programming languages as well these days. And if you use that assembly, this component, this system component, then it implements automatically also everything that the W3C standard asks for. So for instance, the W3 standard has something called an XML document. So here we create a new XML document called doc. And in the XML specification of the W3C, there's a function called load. And this load function includes a URL. So here we have an implementation of that URL as a file, local file URL implemented. So I can have XML file stored on my disk, and with doc.load, I can load the XML document into my memory. So the parser starts working, reads the XML document, creates all the internal structure, all the objects, all the relationships between the objects. And now in the next step, I can start to work with that document. So at that point in time, the document is loaded. And at that point in time here, I can create a node list NL, and I can say, I can go to the document element function of the XML document, and then not the document, it's a document element function, it's a root element, and ask for the function get elements by tag name. So I can ask the parser or the object to search for all the nodes with the name alter. And the result is returned in our node list, which is also specified as part of the XML specification. So the result here is I can say, okay, let's print our node list dot count to string. So I can print here how many elements with the name alter are in my document. And if you go to the debugger, in the debugger window, you see here that is a debugger window sitting on top of this node list. So you see here all the different. No, sorry, it's not the node list. It's a complete set of all the objects currently available. And you see here all the names of the local variables that the debugger shows here All these names, you can also read about them if you look into the XML, into the document object model specification from the W3. First child, child nodes, has child nodes, inner text, inner XML, is read-only, last child, local name, all these kinds of things are part of the specification and are implemented in this context here as part of a system assembly or system component. And this is similar to other programming languages as well. Okay, so that's the DOM object model. And I think it's probably already clear. Both approaches have their advantages and their disadvantages as usual. The SAX parser's advantage is it's super fast for very, very big documents. Very efficient because it's so simple. It doesn't have to take care of any kind of context or anything. And therefore, it's simply fast if you need that. And it can deal with super big documents. Advantage is you do not have any luxury. There's no context available, no grammar, no help, no anything. You have to deal with your SAX parser in every context. You have to find your own solution if you need some context. If you want to count only the second attribute or the second element with some name, you have to create the necessary infrastructure for this in the necessary counters in your program to do the counting and to also check the context that you're looking for. This is totally different if you're looking at DOM parser. The DOM, the document object model approach, is full of luxury. It's first of all, it's a standard. That means you can use that with every kind of programming language, every kind of system that supports any kind of support for the document object model. Context is maintained by the DOM parser. You can modify things, and the DOM parser takes care of any kind of modification of your current model, and it usually comes with lots of other support, other additional tools. So from the developer point of view, it's pure fun to deal with the DOM parser. The disadvantages is, of course, all this luxury comes with some side effect, and the side effects is it takes, of course, memory. It takes storage. If you want to have all these different objects in memory, then this takes some of your computer's resources. And that might mean if you deal with very, very large documents, then you might have to take a different approach, either going with SAX or splitting your document object model documents, your XML documents, into smaller pieces. In the normal situation, I would say the document object model plus a normal kind of XML documents with a couple of megabytes of data included, the document object model with a computer power of typical systems these days, there is no real disadvantage. But if you have to deal with gigabytes or even terabytes of XML documents, this might be a different story. Okay, so in most of the cases, there is no big reason, no big deal to decide, and the decision is usually the DOM parser. But if you have to deal with very specific situations, it's good to know that there's also the SAX parser available. Okay, so homework. And this is really important because this specification will meet you directly or indirectly so many times. So please take a look, go to the W3C site, take a look at the document object model specification, skim over it, try to understand how to learn it, not to learn out, but how to read it. If you like to learn it, that's good as well, but you don't have to learn all these different things. That is useless waste of brain power. But you have to know where to look at and how to look at things there, and know the structure, which is important to find stuff faster. Okay, so to learn this, here's a challenge. When we're talking about a level 3 parser, the DOM level 3 parser for XML nodes of element type, of node type element, so what kind of methods must be supported by a level 3 parser? Okay, which methods must be supported by a DOM level 3 parser for XML nodes of type element? So make sure that you find the answer in the specification to this question. Another question here is, what should a DOM level 3 parser deliver to the following method call? And the call is called getElements by tag name, and then the string for the element name. So what type is returned by getElements by tag name? The relevant information can be found here at the technical reports of the document object model. Have fun, and if you can answer the two questions, I'm sure you have some experience with interaction or with reading, with searching for answers in this specification. And as a third question, if you are learning with a team, ask your teammates a question which they can answer by looking into the specification. So find out a good question that you ask your teammates, and they should answer that question to you using the specification.